titles here, calculating, bounding boxes. Instead of the old title. And as promised, we will iterate over our meshes. So for each mesh, we will recalculate some basic bounding volumes. We also need a method for that. Let's see. How are we supposed to call the render utilities for that? Does this get the rendering data structures? It does. Yeah, so let's do that. Even though it's not part of that, we could perhaps do it in terms of models, physics, systems, global settings, models, meshes, game object data. Do we want... It's strictly not a part of the renderer. It's strictly not part of the renderer. It's more like a game object related thing. Let's do some game object helpers, but they do preferably know about the rendering types. Well, we don't need to actually do game object helpers. Namespace exe and namespace utils. And we want to include the game objects data, which will give us access to our math library, which is pretty great. So let's do something like B, or rather bounding box, and add a bounding box at least for now. Let's do a vector minimum point, vector of maximum points, initialized as 0, 0, 0, 0. And the same goes for this. vertex data and so forth is just, let's see, let's close some of this. I don't need it right now. So we want something like a bounding box for a calculate bounding box from a set of vertices in terms of avoiding having to copy all the vertices. Let's just close these. Instead of having to copy all the vertices over when we build our meshes, let's see, we read them into our float 3 stuff here. Yeah, basically we didn't need to do a vector, but I think it, since we're gonna do, maybe I just want to, for now, create a float 3. Yeah, since it will be far easier to check and probably calculate in terms of, yeah, we're just gonna check some values, compare them. I guess we could optimize that eventually, but yeah, it's not a high priority. This will just be something that we easily will build out. We will calculate the bounding box. We will take in a vector of float, the float, g floats by reference, vertices, okay, we need to include the vector. There we go. And a const unsigned int offset, since we will be passing several meshes and we just want to give it a reference to the underlying vertex data structure and then offset into that. And we also need to pass in the vertex count, of course, because otherwise we can't discriminate, or rather specify our range. There we go. Whoops. There we go. So we simply iterate by specifying that we want to iterate from the offset for some amount of vertices inside our vertex data structure. So for each vertex, we want to store a float min x, which is going to be 0, float min y, which is also going to be 0, and float min c, which is also going to be 0. And we simply iterate over all the vertices and ask, does this vertex lie under our current min x? If it does, set the min x to that x coordinates. Remember, we're trying to calculate the min and maximum corners of the mesh. And lastly, the min y and min z. There we go. And then we do the same, but for the maximum. So we create another series of floats here. Let's say we do a float max here. What is the float max macro? Macro C++. Let's see. Float min and float max. So this will be float max because we will always find something that is lower than that. And we do the float min here. That is way more robust. There we go. And then we check, and we of course need to rename this max, max, max. And then we create a bounding box result, which we return, and the result min point dot x is equal to the minimum x the minimum y and minimum c, minimum y, minimum c. Yeah, and we set the result max point max to the max x, and let's see c. Yeah. And we return that. Let's see. Let's do some application. Okay. Game objects, game object help us. All right. We want to create a vector of bounding boxes, base mesh boxes, and we would like to base mesh boxes in place. Whatever we get from the utils of calculate bounding box from our information here. Let's see, let's just do temp utils. And we want to obj reader get vertices, and we want to pass in our mesh number of vertices and the mesh vertex offset. And yeah, we would like to debug this just to see what we get out the other end. So of course we need to change the algorithm so that it works, because right now we are not comparing correctly. This needs to change, of course. We only find the minimum point. And we will look at this. So it says that the minimum is -1, -1, -1, which from my knowledge of the base mesh here is fine. Let's do another calculation. Yeah. That definitely also works. I think that was what was the floor. This is a wall. Yeah, and this is a bullet, I think. Yeah, and that's it. All right. So now we have our base bounding volumes. Then we would like to maybe we would like to actually store it inside a vector, because we will do translation of each point actually by multiplying by the matrix. Not that matrix, but if you know what I mean. Let's do minimum point equals min x, min y, min z at 0. Let's do that instead. We do max x, max y, max c at 0. This will still work, I think. Yeah. So now we do our calculations, then each object in our object, game objects. We want to calculate if obj it has a mesh, if it has a transform, and if it has a bounding box, we want to calculate let's just do something temporary here. This will be a member variable, bounding box object boxes. Let's see. If it does have all these things, we want to calculate a bounding box. So we probably want to yeah, of course we need the transform, which we have created up here. Oh, not there, that's the textures. Here we create the transforms for the objects. And we want to multiply the base mesh bounding box vectors by the transform. So we ask it to get the bounding box temp from that vector. Then we will do temp minimum calculations by multiplying that vector times the transform matrix, but we have not implemented any math for our matrix calculation. And actually, when we're about to do that, I think the last component of the vector is supposed to be a 1 instead, as since we do the exact same thing here whenever we want to float. We actually set the last one as a 1, so therefore we do like that. Otherwise, the vector times matrix calculation doesn't get handled correctly. So we will do the same thing here inside that. Let's just space this out so it gets a bit more readable. And then inside our math library, we want to create a vector times matrix function, matrix multiply. Yeah, this is some old stuff. Yeah, let's see. Yeah. Vec3 multiply matrix, and we take in a reference to our vector and our matrix. and then we return something. Right now we're just going to return a G vector. Yeah, maybe it's time for that break. Anyway, because yeah, I'm starting to feel really hungry. Um, let's see. So, position vector, multiply, transform, matrix, column major. Let's see. Yeah, so that's viewpoint into the let's see. Either way, we will just end up getting the wrong information, and we can always change the algorithm a bit. So yeah, multiplying, there we go. So each column gets multiplied by the x. So this is row, this is column. Yeah, let's just try to interpret the vector as a yeah, that's fairly easy since we have column major matrices. So yeah, we just isolate the thingy there and set the and add them all up. Let's do that. So every component. So this means this is a product and a summation. So if we do additions, so if we simply multiply the x by the first column, we just have to shuffle them around afterwards. So if we this is a segment. This is a sort of a vector. In itself, it's a column vector. But I would like to yeah, so x gets multiplied by that, by that, by that. Yeah, it's just basic. Let's see. Intel intrinsic guide multiply Come on, Intel, wake up. No time to be slow. Uh, uh, uh. Uh, mask, blah blah blah. Let's try to add a 128. Doesn't help. Or rather, mm mole. We do not want the high word. We would just like multiply single. No. Let's see. There we go. Lower. No. What's the right intrinsic? Is it just, oh, that's for the double round. No, we don't want to round anything. Is it just, no, that's copying. Is it just elements? Yeah. Yeah, from 0 to 3. Yeah, so this was the one I was looking for. So yeah, so each component of the resulting vector in terms of multiplying the vector. Let's do a vector here. Result, which will be the multiply, not ss, right? It's ps. And we multiply our vector by the matrix first column. We step into that. So here we do math vector 3 multiply matrix. So let's do the minimum point and pass in the transforms of the object transform. Let's see the underlying transform, of course. Yeah, so this is supposed to call the vector multiplication method. Let's see where we end up. So our vector has the data 0001 for some reason. I'm not entirely sure why. And our matrix has the first column of something totally weird. Well, that's not gonna work. I mean, this looks more like garbage values. Or rather, no, that I looked at the wrong place. Yeah, this has some transform information. Yeah, and our vector was empty for now. Let's see our result. So minus 20, meaning that the first column here, yeah, you could get that the one gets multiplied by the minus 20, and these are all multiplied by 0 since our vector doesn't contain anything. And let's just see for another version of this. Our vector still doesn't have any information, which is pretty weird. I mean, I'm pretty sure this is not correct. I mean, base mesh boxes, the first one. The second one. The third one. Yeah. They just get initialized as zeros. Oh, it's because I never add them. Oh my god. I forgot to actually copy them over. So let's see. We can remove that breakpoint, and let's see. Our vector contains these information, which is the minimum point. The result vector ends up containing some translated minimum points. Yeah, so this will contain the X position and some scaling on the X-axis. Yeah, I think this will end up working nicely. So yeah, we do the first row. Let's do call one. Let's see, so we want to multiply these. Or rather not multiply, we would like to create a vector here, result, add, I think it's the PS one, right? Yeah, we add all the elements together. So first we add call one, call two, then we say result is equal to the result and call three, and then we do the last thing for our final result. And now we should have the translated vector stored in the result. And our result. Yeah, let's try that out. Let's try that out. So if we step into this, or rather, we would rather actually step into this part of the loop because we don't want to observe and we want to translate the maximum point as well. Whoops. There we go. And we want to store that into our in-place back here. Let's just move that. Temp. Let's just move that as well. Since we will be recreating the structure, and then we just want to check what we ended up with. So we have object boxes which we have 4 of. Are we creating? Actually, I'd expect one more. Oh, maybe we do not set it correctly anyway. That is probably because of the rotation. Anyway. Let's try something here. G vector center. Is that? Let's check this out. I think this is the floor. Yeah, if we negate in our math library, we have something where we negate a vector. Do we just multiply by -1? Negate. Ah. Let's do math vector negate. And then maybe half of that. Division. G vector. Maybe we just want to, instead of multiplying by a scalar, we want to divide. Divide scalar. And instead of, we do division There we go. Math vector divide scalar, and let's do 2.0. We want to step into here and calculate the center. Let's see, this center is -40. Okay. And let's do a vector of g vectors centers, where we centers and place that all right. Let's see, whenever we create our object, transform, usually the objects, why does it get created? Do we, let's just step into this and see our object here, bounding. I mean, this is not supposed to happen because no one has a bounding box. Great. But this one ignores it for some reason. Let's see. I mean, the object. So yeah, now we do not create any bounding boxes. Let's just do, I'm really getting close to that break. So we create the floor. A bounding box, box index. We create that. There we go. So in terms of our floor, we create that. What? Well, you definitely got something wrong here. It's because I used the same object, I just copied. That's of course a mistake. Yeah, so everything just gets copied here. Then after copying that, I set it to -1 so that no other object will have a bounding box. The rest is supposed to get skipped, which they get. And then we would like to use this function. Let's just copy all of it. And then tell the algorithm to create something that takes our centers 0 and this one as our x, this one as our y, and this one as our z. And we add with a semicolon here. Let's just test this out. Okay, we can't do that for some reason. Um, uh, uh, so let's just do some debugging here. Is this a problem? Yeah. Oh, we haven't created our objects yet. That is why I'm calling this too early. Yeah, so let me remove this code. Put it into some comment here. And then actually store our bounding boxes on our application. Bounding boxes, bounding boxes. So instead of using that, we do place it like that. We move this code someplace else after we initialized our data. So now we just create the bounding boxes, calculate them, and then after we're done creating all our stuff and setting up the renderer and creating our data structures for whatever debug we might want to use, we would like to for const auto reference box in bounding boxes, we would like to calculate the center of it. At least by this method, and then we would like to draw a arbitrary bounding box around somewhere in the scene. Yeah, so it gets created around the center here. Okay. Could we perhaps tell the walls to have bounding boxes then? Because it's hard to debug whether it gets placed correctly. So this is the meshes, this is the objects. We would like for it to have a bounding box. This wall, this wall, this wall, and this wall. Alright, all walls will have bounding volumes. And then we can test out by shifting the calculated center. Oh, we didn't actually use the center, so my mistake. Anyway, we will take the first one and then add the X component, first one, add the Y component, and last, oh, whoops, and add the C component, and this might work as intended. So now we should get a wall. Yeah, so it finds the wall. All right, but for some reason it's offset down to the ground, so our calculation of the center is not correct. Division by 1, what does that do? Okay, we end up somewhere weird out there. So that is definitely not correct. Maybe 4, let's see. Nope. The 2 was at least on some of the axes correct. Yeah, it seems like only the Y is not calculated correctly. I mean, but it, let's see. So the center of this bounding volume is here. So for some reason, yeah, and this also gets flipped, rotated. So the point is too low. Let's see. Time to Google some help. Center from for box, minimum, maximum, corner. Find center. Find center of bounding box. So the vector from the minimum to the maximum. Let's not negate this then. Then we'd get the origin. Is it commutative? Yeah, it is. But subtraction isn't. But that, let's see. Right. Well, it's the same. We might still be doing the wrong translation. Scaling the vector by adding. Yeah, I think I was supposed to do that. Yeah, so vec multiply. Let's do that doesn't change anything. Let's try it out here. Am I not transforming things correctly? Is that the problem? I mean, let's try number 4, perhaps. Let's just remove this for now. Subtract. We're getting closer at least. Mm. Let's just step in and debug this. We're way off. Let's see. Our center is the first one. It's very far off. Mm. Mm. So, we calculate the, yeah, of course. So the center is, what we were doing were actually correct, I think. Let's see. So the coordinates divided by 2. Let's see. First one. The x is 0, 0. The y is minus 15 for some reason. And the c is 24. Let's look. I think I might be translating the things wrong, but that is the floor. Is the floor actually showing correctly? I think so, yeah. The floor is showing correctly. It doesn't get translated either, so it's a fairly fine thing to compare to actually. Then the first center after that gets calculated to be at minus 15,000. And actually, let's check what object it is. Let's not use the breakpoint for now. So yeah, I think our translation is wrong. Our objects. The first is the floor, the next one is the negative x, meaning that it's supposed to be over to the right, which it's not at all. Yeah. Let's see. The first object, bounding box 1, fine. The next object, bounding box 1. And we see the minimum points, the maximum points. So on the z-axis minus 40. On the y minus 48. Yeah, the y is definitely not correct. And we do create the transform. The actual, yeah, we might want to. Let's just test this out by transposing this. What do we call it? Transpose, store flow, blah blah blah. That's not it. We just transpose it first to test whether it's our ordering here. Whoops. It's not our ordering. It's not our ordering. At least so it doesn't seem. So the transpose does nothing. I mean, is it because of my calculation of the yeah, for some reason. Well, the center is somewhat at 0 at least. Some parts of the calculation is correct. Let's see. Because it's supposed to be 0 on the C and 0 on the, no, at least on the C it's correct. But minus 15 here. Let's see. Oh, 5. Yes, I think. What a kind of scaling do we do in terms of the floor gets positioned? Yeah, so actually Yeah, I think I'm. Let's see. Oh, transpose the result. Transpose a vector. Is that actually something you can do? Yeah, you could transpose it, but it doesn't change the underlying data structure. Let's see. Uh, let's see. Let's find some resources on the math. Um, uh, uh, yeah. Uh, um, let's see. I already know all that. Matrix, vector multiplication. Well, I would think that you could simply so yeah, let's see. Do we have a breakpoint here? Yeah, we do. So the centers 0, 0, 0, blah blah blah, 0, 0, 0, blah blah blah. All of the information gets encoded somewhere else because yeah, it's not really working. But let's try to do the transpose again. This is supposed to change it so that something at least gets flipped. Then we end up with a 1, with a 1, with a 1. That is not entirely great. Let's try to look up the bounding volumes. The first one, minimum point. Minus 20 on the x-axis. Yeah. Well, that is not correct, is it? And the maximum point. That doesn't seem to be right. I'm just gonna copy this and comment it out because switching it on and off seems something that I would like to be able to do right now. Let's see, bounding boxes. Or bounding boxes here. First one. That's at least better for the y-axis. Yeah, we offset the center by -5. Do we scale it? I can't remember. Let's see. So, no scaling. Only translation along the y-axis. If we do not do any translation for now, let's just do that. Then our bounding volumes -25, 25. And how big is it? Let me just look up the model. Let's see. So our floor, this is just the mesh thingy. So in terms of mesh space, you would have these coordinates, meaning -20, -0.25, and -40 would be the in mesh space. 20, 40, and there we go. Yeah. So this is actually without any transformation. Without any transformation at all. But let's just close that down for now. We don't want the materials, the lights. Textures will be open. The meshes need not be open. Let's see. The objects themselves do not need to be open right now. So if we revert, let's see. Okay. There we go. We close these. Yeah, I reset it so that the middle of it was supposed to be the build resources, not that one. There we go. Yeah, so that the top of it is supposed to be at 0 y. Yeah, let's see the center for the floor. 0 y is the minimum, or what? Oh, not the centers. I mean the bounding volumes. The minimum point, that's actually supposed to be -5.0. And the maximum point is supposed to be O here. Yeah, so it doesn't translate them. That is the problem right now, which means that yeah, Right now, nothing happens when we have a transform. Let's see. So if we transpose it and step into the function up here, because we obviously saw that that was not correct. That is not the center of the floor or minimum ranges of the box of the minus. Yeah, that's not correct either. For some reason it doesn't calculate the minimum rate correct. The maximum division by 2. Let me see. I don't scale it, right? I'm pretty sure I don't scale it. I don't scale it at all. I'm supposed to translate it, which also happens to be what we're doing. So calculate bounding box. The minimum y. Yeah, I'm not really getting that. So if we do nothing here, right now, where would that get us? So our bounding volumes are at the original mesh ones. There we go. Yeah, so maybe our vector matrix multiplication isn't that great after all. Yeah, it might be wrong. Yeah, this is untranslated bounding volumes. These are supposed to be the same for the next ones. -10. Yeah, they are. So yeah, it's our translation of the vector. That is wrong. For some reason. And that y. Yeah. transform matrix vector position multiplication. Uh, uh, so this times this times this. Uh, hmm. Uh, Am I not doing this correctly? Mm, let's see. So it will end up being x times a plus b times y, c times z. That will be the x coordinate. So yeah, maybe we're not doing that right. Let me just look into it. So the X component is supposed to be multiplied by, well, I think this is wrong, yeah. Yeah, I think this is wrong because right now we multiply each X component by correctly the first column of the matrix, which is fine, but the way we end up with our result, at least I think so. The first component is supposed to be made up by the first of this multiplication. But I need to shuffle this beforehand. Yeah, because right now I just do the X every time. Yeah, that's default. So isn't that correct? Yeah, I think so. I need to shuffle it. So let's do first do X times, I mean, are we, wait a second. So this takes the, yeah, I'm doing this wrong. This is only correct for the X. Or rather, let's see, yeah, this is not correct. So the first column of the matrix is supposed to be multiplied by x's only. Which it right now doesn't. Yeah, so let's do the vector temp mm permute. Yes, let's do the vector and then shuffle. And we want the last one, and then we want everything else to be the X component. And then we want to multiply the temp. Then we want to shuffle it up again and multiply the Y components with the second column. And then we want to shuffle up again and do You just add this actually. Yeah, you actually just add it. Yeah, so this is the C component here. Uh, then do y times column 1. Then do C times column 2. And instead of that, we do like this. I think it might end up not being correct in the last part of it, but anyway, let's do some recompilation here. Our vector is minus 20, minus 0.25, and minus 40. And that means our first component is minus 20, which is our x here, our matrix, first column. Yeah, so we should end up with minus 20 and then 0, 0, 0. So column 1 is supposed to be, yeah, that is correct. Then we would like to take our y, which is minus 0.25, and multiply that by, yeah, so we get 0, 0 minus 0.25. Let's see our column 2 here. Yeah, everything is negative, but besides that, it's fine. Then we calculate our column 3 by taking our c-axis, which is minus 40. So this is supposed to be minus 40, yeah. And then our result is going to be and I actually think that's correct. I actually think that's correct. So our bounding box center, it looks promising. It really looks promising. All right. Maybe we just did some math totally wrong. Yeah, we did. Anyway, yeah, maybe you could do this faster some way. Anyway, it does seem to work finally, and that is a great set point for uh, adding our bounding volumes. So the center, the let's try to store this in a distance and just debug it, because I would like to store it and then calculate the center anyway. Let's see. I would like to see if I can just extract the distance here. So the distance, well, I can't. Or rather, maybe I can. Maybe it's, no. Let's see. So that's not the distance. Let's try moving that back in and then saying does it minus? I think it's minus. No, sub is the right one, right? Yeah, sub. Subtract these two. Let's just see. The distance. What does that tell us? Yeah, so we get the distance by subtracting these two from each other and then multiplying by 0.5. There we go, the distance. Yeah, so the radius and yeah, that's the radius information. We do not need to place it. We would like to draw them all. We will of course end up having a lot of trouble here. Let's see. Build debug information. Const unsigned integer. Integer. Bounding debug. And just +2. Let's just do that. And let's change the method call. Oh, we're getting really close now. Can you feel it? Now we will take our bounding boxes and add the size. I would actually like for this to be able to be set as 0. There we go. Then we create space for our bounding volumes. Let's just do center, center, center. And the distance is supposed to get initialized by the distance first part, distance second part, and distance third part. And we would like red bounding boxes for, oh no, we would like green ones, because I think we will use red to indicate that we have a collision. So does this work? Yeah, it does. Yeah, and then we just adjust the padding. We could actually move this somewhere else. Bounding volumes. Let's move this down here, debugging stuff. Let's just create a headline here, debugging stuff. Debugging stuff end. There we go. And inside our renderer, I would like to have a far smaller margin on the bounding boxes, or rather padding. Let's see. Build debug information. Oh, wait a minute. This is the scaling. I'm supposed to adjust this maybe like that. The color will, yeah. There we go. We now have completely built debug information for our bounding boxes. Great stuff. Great stuff. Now I need a break. But this is a really great point to end the video. Hopefully you found it helpful, inspirational, or something entirely else. Feel free to comment, like, or subscribe. Yeah, follow on Twitch, follow on YouTube. Support the channel if you like. In the next video, we will be setting up some sort of collision mechanism and whatever utilities we need to test that. Yeah. So follow along. I don't know when the next episode will be. Maybe tomorrow, maybe tonight. It depends on how much time I'll end up having. Yeah, maybe I'll do it in a short while. Yeah, you'll just have to wait and see. Yeah, but hopefully